Venus should not be dead. By every measure, it should have been Earth's twin. Similar size, similar mass, similar distance from the sun. And yet today, Venus is a furnace hot enough to melt lead, wrapped in clouds of sulfuric acid, with surface pressures that would crush a submarine. Something happened. And whatever it was, it didn't just make Venus hostile. It erased a world. This is Still Unexplained. Brief explorations of unsolved mysteries. My name is Mark. Tonight's mystery isn't hidden in a forest, a government file, or a locked hotel room. It's hanging right above us. Because Venus didn't just turn hostile. It collapsed. For much of the 20th century, Venus was imagined as a swamp world, a humid planet hidden beneath clouds. That vision turned out to be wrong, but the truth may be even stranger. Over the last few decades, planetary scientists have gathered mounting evidence that early Venus may have been habitable, not briefly, not marginally, but for hundreds of millions, possibly billions of years. Models suggest Venus once had liquid water on its surface, temperature similar to early Earth, a stable atmosphere, possibly shallow oceans. Some simulations show Venus remaining temperate longer than Earth has existed, which raises an unsettling question. If Venus was once alive, what killed it? The leading explanation is something called a runaway greenhouse effect. As the young sun slowly grew brighter, Venus absorbed more heat. Water evaporated, water vapor trapped more heat caused more evaporation, a feedback loop. Eventually, ultraviolet radiation broke water molecules apart in the upper atmosphere, hydrogen escaped into space, oxygen reacted with the surface, the oceans were gone. Once the threshold was crossed, there was no return. Today, Venus's surface temperature averages around 460 degrees Celsius, or about 870 degrees Fahrenheit. Hot enough to melt lead. Hot enough to sterilize a planet. But here's the problem. This explanation may not be enough. The runaway greenhouse theory depends on when Venus crossed the line. Recent climate models suggest Venus could have remained habitable much longer than previously believed, even with higher solar radiation. Some models show stable conditions lasting up to 3 billion years. If that's true, Venus didn't slowly bake. It flipped, which implies something changed suddenly. One possibility is catastrophic volcanism. Venus shows evidence of massive volcanic resurfacing, possibly within the last few 100 million years. Lava flows cover nearly the entire planet. Some scientists believe Venus experienced a global volcanic event that released enormous amounts of carbon dioxide and sulfur compounds into the atmosphere, enough to thicken the atmosphere, trap heat rapidly, trigger irreversible climate collapse. But here's what makes this unsettling. Earth also has volcanoes. Earth has carbon cycles. Earth releases greenhouse gases. Venus crossed a line that Earth hasn't. Yet. Another theory focuses on what Venus doesn't have, a strong magnetic field. Earth's magnetic field protects our atmosphere from being stripped away by solar wind. Venus lacks that shield. Some scientists believe Venus once had a magnetic field and then lost it. Without protection, solar wind could have stripped away lighter atmospheric elements, destabilizing the climate and accelerating collapse. But once again, timing matters. Did the field fail first, or did the atmospheric changes kill the field? No one knows. One of the most haunting clues comes from Venus's atmosphere itself. Measurements show an unusually high ratio of deuterium, a heavy form of hydrogen. This suggests Venus once had vast amounts of water, which later escaped into space. But how much water? A shallow ocean? Global seas? Some estimates suggest Venus may have had an ocean equivalent to Earth's Atlantic. Others suggest far more. The planet may not have just lost water. It may have lost habitability itself. This is where the mystery turns uncomfortable. If Venus was habitable for billions of years, life may have emerged. Not intelligent civilizations, not cities, but microbial life. And if that's the case, Venus didn't just lose water. It experienced a planetary extinction. Some researchers even speculate that microbial life could have migrated into the clouds as the surface became hostile. In 2020, scientists detected phosphine gas in Venus's atmosphere. On Earth, phosphine is associated with biological processes. The discovery remains controversial, but the question lingers. Did Venus kill its own biosphere? Venus is often called Earth's twin, but maybe it's something else, a mirror, a future that almost happened. The physics that destroyed Venus are not exotic. They are familiar. Greenhouse gases, feedback loops, atmospheric thresholds. Venus shows us that planetary death doesn't require an asteroid. It only requires imbalance. What we still don't know. We don't know when Venus lost its oceans, whether the collapse was sudden or staged, whether volcanism was the cause or the consequence, whether life ever existed there, or whether the process could happen again elsewhere, including here. Venus doesn't just challenge our understanding of planets. It challenges our assumptions about stability. Venus reminds us that a world doesn't need to explode to die. Sometimes it just changes, and once it does, there's no way back. This has been Still Unexplained. Thanks for listening.